All right, so welcome to video number 2 of the BLENRG from ST. This is the same setup I had before, and it actually is the same code, so we should still be receiving the same messages as we had on the last video. Connection is the same. Right now, it does not have any Bluetooth functionality. It's just the ARM processor sending data back to this. In this video, we are going to make a discoverable and we'll be able to connect to it. We'll also set the name and we'll add an AT command so we can change the name on the fly from the Pico. So the idea here is that we're going to show it in this phone. So we'll see the name there and then we'll use this Android phone to connect to the HM11 and send a message. This will get relayed to the Pico, and the Pico will send a message to this one to rename itself, and we should see it there. Okay, so we are going to start by setting the framework to have an AT command capability. Before we go there, let me bring this up again. So this is the person that has the he sells the development boards for this Bluetooth device. They're inexpensive. He also has a template, which is the one I started with, you can download for Visual Studio Code. And he has a message board, and obviously he sells the boards themselves, the development boards. So if you need one, get it. So we're going to be using a couple things. We're going to be sending the power level, and we're going to send the full name as well so we can see it when we scan for Bluetooth devices. And we have an example here of how to send that data. So let's go back to this. This is where we left off last time. The difference is that I added these two lines. This is for data coming in. We only defined the data going out, the TX side of it. Now we have RX. So we're going to move this code to a better structure, a class, to handle AT commands. So let's do that first. We'll go to our include of C++, and we'll add an AT header. That's just the file name we're going to select for this. We'll also add the source, CPP. What do we need here? If defined, this is required because we're using C++. Okay. So we'll copy that part, extern. This is just to make whatever we put in here to make it visible to C, and also to the C part of it. And also we should be able to see, how to put this. So from C++, we'll be able to see the code in C, and from C, we should be able to see the code in C++. It's a little convoluted, but that's how it works. Okay. So here, we'll put the first include. That will be the AT.header. Okay. And here, we'll add one std.io, and we want to define if not defined, then we define it, and if we'll create a class here. The class will be named AT, the way it is there. We need a parameter for the constructor. This will be a 32-bit integer. We'll call it speed. And if you've seen my other videos, you've seen this class before. This is for my public vars and my private vars, and then one for functions. Okay. Let's see. What do we need? So we need a constant int for our maximum value of buffers. So we're gonna keep it at 100 characters. We need a buffer of that size, so max size. We'll initialize it. Let's copy this because we're gonna use a few of this. We need a field, actually, we need a message. Okay. And we might need a second one. We'll call it raw message. We need a field name and a command. The command's going to have three parts: the initializer, which will be AT, the command, for example, name, and then the value of that command. Okay. We need a way to know when we have a new message. Is that one too many? Yeah. It's false. What else do we need? We need functions. One to add characters. We need one to send messages. This one is going to have a variable number of parameters. One to parse the message. We'll call it parse command. We need one to see we have a valid AT command. So AT command. It's too many letters. I think that's it. So let's move this over to the source file. And let's move this over. Did I not copy everything? To the source file as well. And we won't need that or that or that or that either. Okay, so it goes there. And obviously we'll have some errors because we're missing some includes here. Let's just copy them from here. Actually, before we do that, let me copy this over to right there. And okay, let's copy that over. GPL control Uart string. We need some more, so we need the std arguments 1, and I think that's it. So let me compile, make sure there's no errors. No errors. All right, let's add the first function, which is the add character. Okay. And same as my previous functions or my previous videos, I check for control return, also check for line feed, and buffer counter to make sure that this one is not more or equals, if it's more or equals to max size. I don't believe we defined this one. So let me go see. I did not. So that will be set to 0. So if any of those flags is true, that means that we have a message. So let's start by clearing the raw message. Set it to 0, max size plus 1. Now we can copy into message the buffer, max size, and we can do the same for the raw message. Okay. Now we have that. We can do we can clear buffer. We can set the new message flag to true. The buffer counter, set it to 0. Here we also want to, the reason we have this is because I want to capture the, hold on, counter. I want to capture the character that is going in here, because if it's one of those, I'm not capturing it. I'm just copying it into message. So I want to make sure I capture the buffer plus whatever that is. Okay. So else, we'll just add to the buffer and increase the counter by 1. Okay. So that will do it for that function. Next is send message. AT send message. We need a local buffer of 100. This one has no relation to the size of the other ones in this function, so we'll keep it at 100. We need to get a list for the arguments, and then we need to get a target. Okay. We'll copy into our local buffer whatever is in message as a formatting and text, and then add the arguments to it. We'll end it. Now, to send all of those characters, since we can only send one at a time, we'll need a loop. Index has to be less than the length of our local buffer. Okay. We also need to check if so we need to check if the buffer, the FIFO or the outgoing buffer is not full. If it's full, we want to wait. So the transmitting buffer, and we want to make sure that it's not set. So if it's set, we'll wait with no operation. And now we can send the data. And this is whatever's in our local buffer, using one character at a time. So that should do it for that function. Next one is for parsing the command. Parse command. We need a local buffer as well, so we'll call this temp max size. This one it does have a relationship in size to our variables. So we'll copy whatever is in message and put it in temp max size. And now that we have this, we can define a pointer and say P will be will point to whatever this returns. The token function, it will be temp and a delimiter. That's the delimiter we're looking for. And we'll say if str length, so we want to make sure that there is something here, but if it's 0, I don't want to continue, I want to return. If it allows me to continue, then I'll copy whatever is in there. I'll use sprintf and put first will be the field name, and we'll add whatever P is pointing to. Okay, we'll add 3 more of this. This one will be for the command and the command value. This one has to be set to null. And since since we don't want to keep all messages if it stops somewhere, any like here, if it returns here or here, we want all the data to be clear on the other one. So what we will do is set the memory there on each of those variables to 0. So first on field name, max size, and then on command, max size as well, and one more, command value, max size. So that should do it. The last function, which returns Boolean, what did we say? It was valid AT command. This one is going to return true or false. So what we need is check the length of the field name, make sure it's more than 0. We also want to check the length of the command, make sure it's more than 0 as well, and the command value has to be more than 0. And in order to validate that this is a valid command, we need to compare the field name and make sure it's an AT command. Okay, it has to return 0 to make sure that it matches. What else do we need? I think that's it. Let me compile. If it compiles, we'll test it. Obviously, we have typos, right? So the name valid AT command is invalid. So valid AT command. Let's see what we have defined on our header file. Valid AT command. What's the difference? Well, I don't see the difference. Oh, the return type is different. Yeah, that's what it was. Okay, no more errors. No, there are errors. Let's see this again. I have a couple of errors. No declaration match for AT at character. At character. Oh, missing a D. A lot of typos. Got a couple more. One more. Max size is incorrect. It's misspelled. And no more errors. So it built a bin file. So now let's go test it. Let's see right here. So do we have it? Yeah, here it is. Okay. So we'll define it here. We'll call it pickle because it's going to talk to our pickle, and the speed will be 1150-200. So we can say add character, and we'll add a bunch to simulate receiving a command. So it should be an AT command. A delimiter. We'll say the command is name delimiter, and then the actual name will be test. Okay, and I control return. We should say pickle parse command, and we'll send it so we can see what's in that command. Send message, and we'll send the individual parts. So that would be for the field name. This will be for the command, and that one for the value of the command. So pickle field name command, and command value. Okay, let's compile. We have scripting errors. We have two. So we have one for CXA and one for GXX. So let's go fix those. Go to the script file. This is what we added on the last video. So we're gonna add some more. First one is CXA. And the next one, GXX. GXX. Okay, so let's compile again. All right, no errors. Let me switch over, make sure we are getting the data. So let's open the application and let's see what messages we are getting. All right, so you can see we're getting a message, empty message, right? It's not coming across. So let's see why. Let's switch to the code. So we're adding one character at a time, and last we add that one, which is the one to signify we have a message, right? So let's go look at this code here. Let's make sure we're receiving the data first. So when we get a character, we check for all of that information. We reset that one. We copy buffer into that. We copy that as well. One more, then memset buffer. So we clear buffer, new message, reset the count. Otherwise, the buffer is increased and added. So this is the issue here, I think. So we have temp defined as max size. We're setting we're clearing the field command and value, and then we're copying what's in message into temp. Then we get a pointer to that. If it points to 0, we return. And then we print that. sprintf. Okay, good. Good. I don't see it. Let's see. Parse command. Let's see. Set to 100. Where is it? All right. Let's send the message as well. So Pico message. All right, so let me show you. So we get the message, we're not getting the command. So parsing is not working. This one is not working. Let's see why not. So we clear that one, we clear this one, we clear this one. We copy message into temp. Temp is defined as that. We create a pointer. The pointer is going to point to this. temp as a delimiter, right? Then we check to see if the length is 0. If it's 0, we'll return, which shouldn't be. We should get some data. So let me comment this out. I commented this line out just to see. That is so weird. Huh. What is it? Oh, okay. Man, can't believe I didn't see this. So the issue is that I need to specify the variable, where the variable is going to go. Oh my goodness, right in front of me. All right, let's compile this and go to the desk now. And we should get the parts, the individual parts, and the message at the end, as you can see. All right, my apologies. I don't like to edit the video, so I'm not going to cut that off. That's what it is. Sometimes you overlook stuff like this, and the results are not valid, right? So there we go. Let's move to the next part. Now, here comes the fun part. Let's do Bluetooth stuff to make this connectable, and so we can see it on the scanning devices. So let me switch to the code. Okay. And now, so now that we tested, now we don't need this, so we'll get rid of it. And this one, we'll get rid of that too. All right, moving on. First thing we need to do. So, oh, I have to go pick up my son. All right, so we're gonna move this file. We're gonna rename it first, BLE config. Move it to this one here. That includes, and we'll move to the bottom. We need to define, we're going to use that structure to define or initialize the stack. So we'll go here and add it, BLE config.h. We need the stack as well. I think we also need the API, and yeah, I think that's all. All right, so now we can say BlueNRG initialize, and we'll use that one. And we can initialize our device. This is a function we're going to create, so we'll create that here. Init device. Oh, I had it copied. Device, you can see. Okay. Our return will be 8 bytes. Set it to 0. Return. Okay. So we need 2 variables. I'm going to make them global because we're going to change this on the fly. So the first one is the address, and we'll define this. It has to be 6 bytes, so we'll set it to a bunch of ones. That's 4, 5, 6, and we'll set the last one to, let's say, 3. Okay, 1, 3. How's that? The next one is the name, or the name holder, or for advertising. So will be the advertising name. We'll define it as 23. I know we can send 23 character length names. I don't know if it can handle longer than that, but I know 23 can't. So in order to enable that, we'll go back to this configuration file. Let's go all the way to the top. And on the next video, when we add services, we'll add the services here. How many bytes it takes is 1 byte per service. And then this how many bytes it takes for the characteristics. They can take from 2 to 5. It's likely it's going to take 3 when we're notifying. Doesn't matter. Let's move on. So this one here, that number 34, what it means is 36 for the GAT and the gap initialization, and 8 for the name. So that makes 44. So it was defined to handle names of 8 characters. We want 23 in total. Okay, so we'll leave 23 in there, and that allows us to use this. So now here, because I want to change it on the fly, now that I have that, I can define just something quick to have a name. So it will be my BLE hello world. Okay, let's see how long that is. It's 21 bytes, perfect. So now we can copy that into the advertising name, temp size of temp. Okay, a lot easier than having to put individual characters. Okay, so now what do we need? We need to call the application command interface to write the config data. And first it takes an offset, which is 0, and then the length will be the size of the advertising name. Sorry, the address. What am I thinking? And now the address itself. Okay. The next one, actually, let's set the power level. So we'll set it 1 and 4, which is the default they use. That means power 0, I think, or the strength should be 0. dB something. Anyways, next one. Now we need the GAT init. This one doesn't have any parameters. The gap init takes a few parameters. First, it takes the role. Role is going to be 1. Peripheral. Privacy, no privacy. Device name. Character length, so it will be the size of the advertising name. And then the handle. We haven't defined the handle, so we need a service handle, characteristic name handle, and an appearance handle. So difficult for me to say. They are 16 bytes, so it will be 1 for service and 1 for the characteristic name, 1 for the characteristic appearance. Okay, so we'll go back to this. It needed the service and the name. Appearance. That's it. Okay. One more. This is the get update. That one, the extended one, characteristic value. This one has a few as well. So first it takes a handle to notify. We don't have one. We'll set 0. Service handle. It will be the service handle. The characteristic handle. The name. And then the update type will be 0. The character length will be the size of the advertising name. And then, can see anymore? The offset will be 0. The value, length, again, advertising name, and last the value, so is the name again. All right, so that should allow us to initialize our device. We need one more, so now that we have that, we should have the BLE, actually BT stack tick, and our own app tick. Okay, so we'll create this right here. Okay, so for this one, this is where you advertise your data. So when someone scans and they see your name, you can send them the name of the device and any other parameters you want to send. So we need to construct the data we're going to send out. So we need a variable. This is called the manufacturing data. And the way we send it, or the way you send it, is you specify, like this one has two types of data. It has the limited discoverable flag. So this one sets how many bytes are to follow. It says 2 bytes for the flag and the value of the flag. This one says there's 10 bytes to follow. So, and then it says this flag means the complete local name. So if it's 10, that means that this is 1 and 9 for the name. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then this one 10. So we're going to send text power, and we're going to send the complete local name. So those two types. Okay. So let's go back to our code. So 2 bytes, and we said we're going to send the text power. This says is 0. And then for the next size, since it's a long name, long name, we're going to specify that this is the size of the advertising name plus 1, because it needs to cover the next byte, and that one is 9. We said we're going to send 9 for the complete local name. But because the name is going to be variable, and to put it here, we're going to use memcopy, so we need to extend this. So we'll put 5 plus the size of the advertising name, 5 because there's 1 spot, 2, 3, 4, 5, and then following that, we'll put the name. So now we can say memcopy the M data plus the 5 bytes, move it forward, and then the advertising name and size of the AV name. Okay, so now we have our data to send. The first command we're going to use is the HCI LE set command response. This one is required if you want Android devices to see the name, so you have to set this one. So this one is size of M data. Okay, and here we want the what is it? Gap set discoverable. Let's see what bytes we have. We have the advertising type. It will be 0. And then the advertising interval will be 0 as well. The max 0, 0. No filters. Local name will be the adv name. Oh, that's the length. Size of the name, and then the name. Nothing for IDs, no list, 0, 0. Okay. So, yeah, we're missing one more. ACI, the update advertising data. This one is the same as this one, so I'll just copy this. All right. So if I did everything correctly, let's compile. Obviously, didn't work. let's fix the typos. Here's the first one, conversion. What conversion? And data. So it says invalid conversion from character to uint. Okay. So this one here, let's just set it to this. There we go. Magic. All right. So let me switch my view, and let's see if we can see it. Let's refresh. There it is, my BLE hello world. So that means we should be able to see it here as well. Let's just wait. So there it is as well. There's the address, 1, 3, and then a bunch of ones. For this one, I have to connect to see it. All right, so it's not gonna let me connect because this thing takes too long, right? So let me comment this line out, compile again. We'll go back to this. And it should come up shortly. There it is. Okay, so there's the advertising data and the address. I don't know where it is. Doesn't matter. Anyways, so there it is. There's the device, right? There's both. There's the my BLE hello world. So now let's add the code to change the name. So that should be something a little more simpler, hopefully. So let's go back to this. So in order for this to work, we have to do a few things. We'll go to the source file IT, and this one has a callback already for the interrupt. And here we're gonna call our AT command handler. Okay, so let's copy that. We don't have that function yet, so we're gonna add it right now. And we'll declare it here, so it's visible. And we'll define it here. Okay. I know we need the another include, that one, just to make it visible. What else do I need? Let's see. So we need the, yeah, there we go. It came right at the top. Type init, init type. There we go, init type. And for this one, we need to define a few parameters or a few properties. So init type, we need 3 of them. It will be the UART IRQ, and the command is enable. And the last one, the priority will be low priority. So NVIC init, yes, that's it. Init type, and then UART IT config. We're configuring the UART IRQ IT. Is that RX? Yeah, it's RX. Enable. Okay, so that will enable that part. Actually, this is incorrect. Let me move this out of the way. Let me init IRQ. I'm gonna set it there. And before I forget, let me copy this down here, enable it here. And now this one for picking up our data. Yeesh. All right. So here, we want to check to see if the interrupt has been set. So we'll say if UART get IT status, and the status is the UART, is that the one? Yeah, for RX. We want to check to see, so if it's set, so we want to check to see if it's set. So if it's set, or actually I should say if not reset, then that means that we have an interrupt, right? We have an interrupt for receiving data. So now that we have an interrupt, we can loop through all the characters that we receive by just simply saying the get status, flag status, and it should be the, what is it? The receiving 509 empty, that one. Okay. And what we need to, let's say, what is it called? UART receive data. Okay. All right. So this one returns a 16-bit data. We only need the first 8. Okay. Let's put another thing here. So now how do we get into our pickle since this is a separate function? Well, what we need to do in order to keep accumulating those characters, we need to define a pointer, and we'll call it that. So that way when we can call it from here, add character, and we need to set the pointer here. And it points to pickle. So now that we have that, we should be able to say here if pickle new message, then we can say pickle new message equals false, pickle parse command. If pickle has a valid AT command, then we can check if the command is something we can handle. We're going to use the name command. So we'll say pickle, not pickle, but str compare pickle command. The command should be name, and it should match if it's 0, or if it matches, it should be 0, I should say. So if that's the case, then now we can say memset advertising name, the size of advertising name, and then we can copy the contents of that field into the advertising name pickle command value, right? So whatever the name we decided to be, we're gonna copy it over command value. Okay. If I did everything correctly, I think that's all I need. So let me run it. I have a typos command. Yep. All right, there it goes. So let me switch my view. Let me see if it's gonna work. How many errors are made? Let's break it. Let me move this out of the way. Disconnect this. So there's my hello world. There's my hello world. So I'm gonna, where's the other one? So I'm gonna use this one to connect to the HM11. Oh, I need to disconnect from it because I'm still connected on this one. So I'll disconnect. It should pop up here now. Here it is, tank. I'll connect and go to the bottom. We're gonna send data as string, and the command is AT. The command we support is name, and the name we're gonna give it, we'll call it YouTube. Okay. We need to send a control return. So if it works, hopefully, when I send it, this name, the one at top, will change to YouTube. Hold on. I connected by mistake. Anyway, so there it is. So let me send it. There it is. It changed to YouTube. If I change it to test and send the control return, where's the R? So when I send it, the name YouTube will change to test. There it is. So now you can discover your device. You can connect to it even though it doesn't do anything yet. You can rename it easy on the fly. Change takes effect immediately. So on the next video, we'll add services to send data back and forth from the phone as a pass-through. So this will be able to connect to this one just like it did with the HM11, and I'll be able to send and receive data, hopefully different types of data. So until next video, oh, the links for that person's video will be in the description. This project files will be in the description as well for you to download. So until next video, I have one more video and then I'll be done with this project. I'm only gonna demo a couple of things and I'm gonna write a complete firmware for this, and then I'll upload that for you guys to download if you like it. But you at least have a starting point where you can create your own firmware for this device as well. What I intend to do with this is the firmware should allow you from the phone enable SPI, UART, I2C, PWM from your phone, and then you should be able to connect any device, read it by telling it from your phone that that's the interface you have and that's what you're going to read. You should be able to send commands back and forth. All right, so till next video, enjoy.